Hello everyone, my name is Stephanie Geisner and I am a second-year PEDS resident. Today I will be presenting my poster, Markers of Branched-Chain Amino Acid and Fat Metabolism in Obesity and Prader-Willi Syndrome. So I'm going to start off by talking about 2-hydroxybutyric acid, or 2-HbA, which several studies have shown to be associated with obesity, insulin resistance, and type 2 diabetes in both children and adults. Specifically, it increases in obesity and insulin-resistant states. The reason 2-HbA rises in insulin-resistant states is thought to be partly related to decreased branched-chain keto acid dehydrogenase activity, or BCKDH activity, which is then associated with increases in fatty acid oxidation. You can see this pathway in Figure 1. BCKDH catabolizes branched-chain amino acids like leucine and valine into downstream substrates like acetylcoenzyme A for the TCA cycle. So, when BCKDH activity is decreased or inhibited, there is decreased downstream substrates, and fatty acid oxidation will increase to create new substrates for this TCA cycle. You can also see in Figure 1 that BCKDH turns 2-ketobutyric acid into propionyl coenzyme A. Thus, when it is inhibited, 2-ketobutyric acid increases and will then turn into more 2-HbA. So we decided to investigate this relationship between inhibition of BCKDH and fatty acid oxidation. Specifically, we compared the relationship between 2-HbA and 3-hydroxybutyric acid, or 3-HbA, which is an endpoint of ketogenic fatty acid oxidation, in 3 male children with simple obesity and 3 with Prader-Willi syndrome, matched for age and BMI. Moving on to the methods, we obtained blood samples in these children while fasting and after a high-fat and a high-carb meal. We measured their hormones and performed untargeted metabolomics via gas chromatography and mass spectrometry to compare the response to high-fat and high-carb meals. We performed data transformation, significance testing, and correlation analysis, as well as univariate statistical analysis. So moving on to the results, the means of simple obesity versus Prader-Willi syndrome are summarized in Table 1. As you can see, there was no significant difference between the two groups in general, and thus they were comparable in BMI, age, insulin levels, and HOMA-IR levels. Of note, however, total and high molecular weight adiponectin, seen here, did trend higher in Prader-Willi syndrome, although again, it was not statistically significant. Our main finding is shown in Figure 2a and 2b. In boys with simple obesity, there was no correlation between 2-HbA and 3-HbA levels, as seen with an R-squared of 0.166. However, in boys with Prader-Willi syndrome, there was a strong positive correlation between 2-HbA and 3-HbA levels, with an R-squared being 0.848. PWS is the most common syndromic form of obesity, resulting from the absence of expression for the paternally inherited chromosome 15q11 to q13. In childhood, it often manifests with symptoms of hyperphagia and progressive development of obesity. As a result, they are at high risk of obesity-related complications, as evidenced by the fact that 9 to 22% of adults with PWS also have type 2 diabetes. Even so, in our previous studies of PWS, findings showed that children with PWS appear to have preserved insulin sensitivity when compared to children with simple obesity. This is consistent with these results in which adiponectin trended higher in children with PWS, as insulin resistance and type 2 diabetes are associated with low levels of adiponectin. We think that this difference in insulin sensitivity could be partly explained by the observed positive correlation seen here between 2-HbA and 3-HbA in PWS, which suggests a tight link between fatty acid oxidation and inhibition of BCKDH. Conversely, in patients with simple obesity, they may have medically decompensated in such a way that the link between fatty acid oxidation and BCKDH inhibition has become relatively weak or disrupted, and this may then lead to insulin resistance and type 2 diabetes. It is extremely important that we understand the mechanism by which children develop insulin resistance, as this can pave the way for future studies to investigate preventative measures for type 2 diabetes in children with both simple obesity and PWS. To end this presentation, our results has 3 main conclusions. 1, children with PWS appear to have preserved insulin sensitivity. 2, children with PWS maintain a tight link between fatty acid oxidation and inhibition of BCKDH. And 3, the difference in insulin sensitivity between children with simple obesity and PWS could be the disruption of this link. Thank you everyone for listening to this presentation. I just want to thank everyone at DMPI who helped contribute to this project and my poster, especially my research mentor Pinar, who has been extremely helpful throughout this process. Please let me know if you have any questions.